Hello friends, welcome back to Webronaq. In this video, we're going to solve a classic C++ interview question. How do you swap the values of two numbers without using a third variable? Now, swapping is something every programmer does, but the way most of us learn it in the beginning uses an extra helper variable. The trick we're looking at today does the same job, but with zero extra storage. Just the two original variables, doing all the work themselves. And we're not going to stop at one method. I'll show you two completely different ways to pull this off. One using simple math, and another using a bit-level operator that feels almost like magic once you see it. Let's start by understanding why we even need a trick in the first place. Alright, before we get to the trick, let's quickly look at how swapping is normally done. Say we have two variables, a holds 10 and b holds 20. If we try to directly do a equals b, we lose the original value of a instantly. It just gets overwritten. So to safely swap them, we bring in a third variable. Let's call it temp. Step 1, we copy a into temp. Now temp holds 10, like a safe backup. Step 2, we copy b into a, so a becomes 20. Step 3, we copy temp back into b, and b becomes 10. Swap done. This is the same idea behind cut and paste in Word. When you cut something, it doesn't vanish. It sits on the clipboard until you paste it somewhere. That clipboard is exactly what temp is doing here. It works perfectly, but it does need that extra slot in memory. So the question is, can we pull this off without it? So here's the challenge. We have a equal to 10 and b equal to 20. We want a to end up holding 20 and b to end up holding 10. But this time, no third variable, no temp, no backup, nothing. Just a and b doing all the work themselves. At first glance, this sounds impossible. The moment we overwrite one of them, the original value is gone, right? Well, that's where a clever idea comes in. What if we could store both values inside one variable at the same time, packed together, and then pull each one back out when we need it? That's the whole secret behind this technique. And we're going to do it in two different ways. The first one uses basic math you already know, addition and subtraction. Let's see how that works. Alright, let's break down the arithmetic method. It's just 3 lines of code, but the logic behind it is really elegant. Step 1, we add a and b together and store the result back into a. So a was 10, b was 20, and now a becomes 30. Notice what just happened. A is no longer just a. It's holding both values, combined. The original information isn't lost, it's just merged. Step 2, we take the new a, which is 30, and subtract b from it. B is still 20, so 30 minus 20 gives us 10, and that goes into b. So now b is holding 10, which was the original value of a. Half the swap is done. Step 3, we subtract the new b, which is 10, from a. So 30 minus 10 gives us 20, and that goes back into a. And just like that, a is 20 and b is 10. The swap is complete. The whole trick is in step 1. By adding them, we packed two values into a single variable. Then subtraction acts like an unpacker, pulling each one back out into the correct place. Now let's see what this actually looks like in C++ code. Here's the full C++ program. Let's walk through it quickly. At the top, we include IOStream so we can print output to the screen, and we bring in the standard namespace so we don't have to write std everywhere. Inside main, we declare two integers. A is 10 and b is 20. These are the values we want to swap. Then come the 3 magic lines we just discussed. First, a equals a plus b. A becomes 30. Then b equals ab. B becomes 10. And finally a equals a. B, a becomes 20. After that, we just print a and b to confirm the swap worked. And the output is exactly what we expected. A is now 20, and b is now 10. 3 lines, no temp variable. The swap is done purely through arithmetic. Now, this method looks clean and clever, but it has one quiet weakness that you should know about before using it in real code. Let's talk about that. Now, here's something important. The arithmetic method works beautifully for small numbers, but it has a hidden trap, integer overflow. Here's the problem. In C++, a regular int can only hold values up to about 2.1 billion. That's the maximum. So when we do a equals a plus b, we're combining both values into one variable. And if a and b are both already large numbers, their sum can shoot past that limit. Look at the example on the right. If a is 2 billion and b is 1.5 billion, their sum is 3.5 billion, way beyond what an int can hold. The result wraps around and gives us a completely wrong number, which means our entire swap gets corrupted. This is the same reason video games sometimes show weird negative scores when you play for too long, or why an old odometer in a car eventually rolls back to 0. The storage simply runs out of room. So the arithmetic swap is elegant, but it's not bulletproof. For safe, real-world code, we need a method that doesn't depend on the size of the numbers at all. And that's exactly what our second method does. It works at the bit level, completely sidestepping the overflow problem. Let's see how. Alright, now let's talk about the second method, the XOR swap. This one works at the bit level, which makes it completely immune to overflow. XOR, written as the caret symbol caret in C++, is a bitwise operator. It compares two bits, and the rule is simple. If the two bits are different, the result is 1. If they're the same, the result is 0. That's it. Different equals 1, same equals 0. Look at the truth table on screen. 0 XOR 0 is 0. 0 XOR 1 is 1. 1 XOR 0 is 1. And 1 XOR 1 is 0. Just 4 cases to remember. Now here's where it gets interesting. Take A equal to 10, which in binary is 10, 10. And B equal to 6, which in binary is 0, 1, 1, 0. When we XOR them bit by bit, we get 1100, which is 12 in decimal. But here's the magical part. XOR is reversible. If you take that result, 1100, and XOR it with B again, you get back the original A. And if you XOR it with A, you get back the original B. The combined value secretly remembers both originals, and you can pull either one back out by XORing with the other. That reversibility is exactly what makes XOR perfect for swapping. No addition, no risk of overflow, and the numbers can be as large as you want. Let's see this in action with the actual 3 lines of code. Here's the XOR swap in C++. The structure looks almost identical to the arithmetic version, just 3 lines doing all the work. But the operator is different. Instead of plus and minus, we're using the caret symbol, which is XOR. Let's trace it with A equal to 10, which is 10, 10 in binary, and B equal to 6, which is 0, 1, 1, 0. Step 1. A equals a caret B. We XOR the two bit by bit. 10, 10 XOR 0, 1, 1, 0 gives us 1100, which is 12. So A is now 12. Just like before, this single variable secretly holds the information of both originals. Step 2. B equals a caret B. The new A is 1100. XOR it with B, which is still 0, 1, 1, 0, and we get 10, 10. That's 10, the original value of A. So B is now 10. Half the swap is done. Step 3. A equals a caret B. The new B is 10, 10. XOR the current A, which is 1100, with this, and we get 0, 1, 1, 0. That's 6, the original value of B. So A is now 6. Swap complete. A is 6. B is 10. No temp variable, and no risk of overflow, because XOR doesn't make numbers bigger, it just flips bits. This is the same kind of bitwise logic that powers things like file encryption, error checking in network packets, and even how WhatsApp protects your messages end-to-end. The operation is fast, safe, and reversible, which is exactly why it shows up everywhere in low-level code. Let's wrap up with a quick recap. Alright, let's quickly recap what we learned. We saw 2 ways to swap 2 numbers in C++ without using a third variable. The first one is the arithmetic swap, using addition and subtraction. It's simple, easy to remember, and works perfectly for everyday numbers. But it has one weakness. If the values are very large, the sum can overflow, and the swap silently breaks. The second one is the XOR swap, using the caret operator, which works at the bit level. It needs a little more thought to understand, but it's completely safe from overflow, because XOR never increases the size of the number. It just flips bits. For most real-world code, honestly, using a temp variable is still the cleanest and most readable choice. Compilers are smart enough to optimize it. But knowing these 2 tricks is genuinely valuable, because they teach you how numbers actually behave in memory, and they come up surprisingly often in coding interviews. If this video helped you understand the concept, hit the like button, subscribe to Webronaq for more programming tutorials, and let me know in the comments which method you found more interesting, the math one or the bitwise one. I'll see you in the next one.